Hello ninth graders. In this video, we'll identify the valence or valency of an element. Recall that the valence shell is the outer energy shell, and the valence electrons are the electrons found on the valence shell. And level K can never hold more than 2 electrons, while levels L, M, and N can hold 8 electrons each. And inert gases are chemically stable for having full or saturated outer energy level, where helium has its valence shell K saturated with 2 electrons. Neon has its valence shell L saturated with 8 electrons, and argon has its valence shell M saturated with 8 electrons also. And at the end of this video, you will be able to relate the lowest dot symbol of an element to its location in the periodic table, define the valence of an element, distinguish between valency and valence electrons in an element, and state the octet and duet rules. Prepare your materials and let's begin. Consider elements in group 1, elements in group 5, and elements in group 8. Do you know why elements of the same group or column have common properties? Because they have the same number of valence electrons. So dear students, keep in mind that the number of valence electrons of an element is related to its position in the periodic table, where elements in group 1 or column 1 have only one valence electron. Elements in column 2 or group 2 have 2 valence electrons. Elements in column 13 or group 3 have 3 valence electrons. Elements in column 14, group 4 have 4 valence electrons. Elements in column 15 or group 5 have 5 valence electrons. Those in column 16 or group 6 have 6 valence electrons. Elements in column 17, group 7 have 7 valence electrons. And elements in group 8 or column 18 have 8 valence electrons, except for helium, where it is found in column 18, but it has only 2 valence electrons. Let's do some applications. We have to identify the column or group to which each of the following atoms belong: potassium having Z equal 19, sulfur having Z equal 16, fluorine having Z equal 9, and helium having Z equal 2. Before writing the electron configuration, we have to mention that the atomic number Z is equal to the number of protons. And in a neutral atom, the number of protons is equal to the number of electrons. For potassium having Z equal 19, the electron configuration is K2, L8, M8, and 1. On its valence shell N, we have only one valence electron, so we can say that potassium belongs to column 1 or group 1. For sulfur having Z equals 16, the electron configuration is K2, L8, M6. So it has 6 valence electrons on its valence shell M. So we can say that sulfur belongs to column 16 or group 6. For fluorine having Z equal 9, the electron configuration is K2, L7. It has only 7 electrons on its valence shell L, so fluorine belongs to column 17 or group 7. For helium having Z equal 2, its electron configuration is K2, and it has 2 valence electrons, but helium is an exception. It is found in column 18 or group 8 with the noble gases. Hydrogen atom exists in nature bonded to another atoms forming compounds like H2, H2O, HCl, H2SO4. However, helium atom doesn't combine readily with other atoms. But why does hydrogen atom form bonds with other atoms while helium doesn't? We notice that the electron configuration of hydrogen is K1 and that of helium is K2. And we know that for the atom to be stable, the K shell should hold 2 electrons. So hydrogen atom needs 1 electron to be stable and achieve the electron configuration of the closest inert gas, helium. Thus, hydrogen form bonds with other atoms. So we can say that the valence or valency of hydrogen is 1. Also, oxygen atom exists in nature bonded to another atoms forming bonds like O2, H2O, CO2, H2SO4. However, neon do not combine readily with other elements. But why does oxygen atom form bonds with other atoms while neon doesn't? If we notice the electron configuration of oxygen is K2L6 and that of neon is K2L8. We know that for an atom to be stable, the L shell should hold 8 electrons. So oxygen atom needs 2 electrons to be stable and achieve the electron configuration of the closest inert gas neon. Thus, it forms bonds with other atoms. So we can say now that the valence or valency of oxygen is 2. Now, can you define the valence or valency of an element? The valence or valency is the number of electrons involved in bonding to achieve the electron configuration of the closest noble gas. So atoms may lose, gain, or share electrons to attain their stability. Thus, atoms are always in a constant struggle to reach the stable state. But what is this stable state? When an atom contains only one shell, the stable state is achieved when only 2 electrons are present in this shell, which is the shell K, and this is called the duet rule. However, atoms having 2 or more shells, the stable state is achieved when 8 electrons are present in these shells, which are L and M. And this is called the octet rule. Let's do some applications. Referring to the electron configuration, we have to identify the valence or valency of the following atoms. Argon having Z equal 18, sulfur having Z equal 16, sodium having Z equal 11, and beryllium having Z equal 4. Before writing the electron configuration, we have to mention that the atomic number Z is equal to the number of protons, and in a neutral atom, the number of protons is equal to the number of electrons. Starting by argon having Z equal 18, the electron configuration of argon is K2L8M8. It has 8 electrons in its valence shell, so it has 8 valence electrons. So argon atom is stable since its outer shell M is saturated with 8 electrons. So we can say that the valency of argon is 0. It doesn't need any more electron to be saturated. Now for sulfur having Z equals 16, the electron configuration of sulfur is K2L8M6. It has 6 valence electrons on its valence shell M. Can sulfur lose these 6 electrons to be stable and satisfy octet? Of course no. An atom cannot lose more than 3 electrons. So sulfur atom needs 2 electrons to be stable and achieve octet rule, which is stability with 8 electrons. Thus, the valency of sulfur is 2. Now for sodium having Z equal 11, its electron configuration is K2L8M1. It has only one valence electron on its valence shell M. Can sodium gain 7 electrons to become stable and achieve the octet? Of course no. An atom cannot gain more than 3 electrons. Thus, sodium atom, which is a metal, needs to lose 1 electron to become stable and achieve octet rule, which is stability with 8 electrons. Thus, the valency of sodium is 1. What about beryllium having Z equal 4? The electron configuration of beryllium is K2L2. It has 2 valence electrons. Beryllium needs to lose 2 electrons to become stable and achieve Dowett rule, which is stability with 2 electrons. Thus, the valency of beryllium is 2. Now we are going to identify the relation between the valency of an element and its Lewis dot symbol. So we'll consider some elements with their valency number and their Lewis dot symbols. Here is sodium having valency 1 and its Lewis dot symbol. Beryllium having valency 2 and its Lewis dot symbol. Sulfur having valency 2 and here is its Lewis dot symbol. Argon, it has valency 0 and this is its Lewis dot symbol. Now we have to compare the valency of each element with the number of lone or single electron in its Lewis dot symbol. For sodium having valency 1, the number of lone electrons or single electrons in its Lewis dot symbol is also 1. For beryllium having valency 2, the number of single or lone electrons in the Lewis dot symbol is also 2. For sulfur having valence or valency 2, the number of single or lone electrons in the Lewis dot symbol is also 2. For argon having valency 0, we notice in its Lewis dot symbol we don't have any single or lone electron, so the number of single or lone electrons is 0. So we can say that the valency of an element is equal to the number of lone electrons in the Lewis dot symbol of this element. So keep in mind, dear students, that valence electrons are the number of electrons in the outer energy level. And valency can be defined as the number of lone electrons that an element possesses, or is equal to the number of electrons involved in bonding for an atom to achieve the electron configuration of the closest noble gas. And the column or group to which an element belongs is equal to the number of valence electrons of this element. As an example, elements of column 1 have only 1 valence electron, elements of column 14 have 4 valence electrons, Elements of column 17 have 7 valence electrons, and those of column 18 have 8 valence electrons, except for helium, which has 2 valence electrons. And an atom becomes stable in two cases. If its external shell K carries 2 electrons, we say that this atom verifies DeWitt rule, or if its external shell L or M carries 8 electrons, we can say that it verifies octet rule. As an assignment, you have to